I'm back. Okay, guys, so we're going to work on chapter 23, questions for discussion. So let's talk about this. Maybe I didn't go over this. Maybe I'm just, really terrible. All right, so why is a lap joint better than a butt joint for bracing? So remember, a butt joint doesn't provide the same kind of strength a lap joint does because the area is not as big. Okay. Why is joint clearance an important factor when we braze? Joint factor affects the mechanical properties of the brazed joint. Surfaces that are too tight don't allow the filler metal to use capillary action. Surfaces that are too loose don't get the full effects of capillary action. We get voids. We don't get the filler metal to go. So the most appropriate or adequate joint clearance is in the range of 0.001 inches to 0.010 inches. Okay. So what procedure should be used in cleaning surfaces to be brazed? Well, we want to make sure that we use a cleaning solvent, a salt bath, a pickling acid, a vapor degreaser, surface oxide removal by sanding, grinding, filing, machining, blast cleaning, or wire brushing. Pretty much get as much off as you can. And if you have to, use like acetone or even soap and water to a certain effect to make sure that your material is clean. Now, why do we need flux for brazing? What does it do for us? Okay, so there can be a chemical reaction from air when we're raising the temperature during the brazing process. So we use that flux to dissolve any oxides and remove them while we're brazing, but it also helps give it a little bit of a tooth for the filler material to actually stick on there. So why should we remove all the flux after it's completed? Well, we don't want corrosion to develop. All right, what do the AWS classification symbols for brazing filler metal represent? So what's going to be in the beginning? It's going to be the letter B, and it's going to be followed by the chemical symbols of the metallic elements that are included into the filler metal. Any numbers followed after with a dash designate specific filler metals within the group. Okay, so it might be -2 or -5, and it's percentage of material in there. So what's the difference? Oh, sorry. Boy, I'm just doing terrible. How should the torch flame be applied to the work to carry out a brazing operation? When brazing, use a slightly reducing flame and do not apply the inner cone. We want to do the outer envelope. And we want to move in a circle. What is meant by liquidus and solidus temperatures? Liquidus is the lowest temperature at which the metal is completely molten, and solidus is the highest temperature at which a metal is completely solid. Okay, so finally, what is the difference between braze welding and brazing? Brazing is a joining process that produces a coalescence of metals using non-ferrous filler metals that have a melting point below that of the base metal. Okay. And braze welding is a joining process that uses a coalescence of metals that begin to melt at temperatures above 840 degrees and below the melting point of the metals joined, and it is not using capillary action. All right, what are some of the advantages of braze welding? Braze welding is able to braze similar materials, but also dissimilars while remaining in a solid state, right? Braze joints have high tensile strengths and it doesn't affect the HAZ because lower bonding temperatures means that we're not changing the molecular structure of a material. Whew, all right, so when should braze welding not be used? When what? When our material will be subjected to high temperatures in service and high stresses. What kind of filler metal is needed for braze welding? Braze welding filler metals are usually brass with approximately 60% copper and 40% zinc, in which produce adequate tensile strength and ductility. In addition, filler metal contains small quantities of tin, iron, manganese, aluminum, lead, nickel, chromium, and silicon. Well, there we go. So how should flux be applied? Well, we want to pre-flux brazing filler metal. It eliminates the need to apply flux while brazing. The flux may be heated into the powdered flux. Another method is to dissolve the flux in boiling water and brush it onto the filler metal before welding is started. So pretty much put it on your filler metal first. So when is a surface hot enough for braze welding? And this one, you guys, it might be on the test, so I want you guys to listen very closely. So if the base metal is too hot, the filler metal will bubble or run like drops of water on a warm stove. If the base metal is not hot enough, the filler metal rolls into balls off the base metal like water would if it would be placed on a greasy surface. When the base metal is the proper temperature, the filler metal just spreads out really evenly. Hope that helps. Okay, during the soldering process, why should be parts held firmly in place? Well, parts want to be held together during soldering so there's no movement. Movement makes what? Misalignment. And when we have a disturbance to solder, it causes it to solidify without making a good bond. All right, so what is meant by tinning copper? Well, remember we talked about tin? Well, we take that soldering copper and we actually put a thin coating of solder over it, and that way it helps us keep the oxides out and make sure that we have a good solder. So how does seam soldering differ from sweat soldering? Okay, seam soldering, a layer of solder is deposited along the outside edge of the joint. And sweat soldering is a process where two surfaces are soldered together without allowing the solder to be seen, kind of like a lap joint or a folded joint. All right, guys, take it easy. Take care.